I'm Annegret Falkner from Princeton. So I probably don't need to tell many of you, especially people of a certain age, but your hormone levels fluctuate a lot over the course of your lifespan. So women whose ovaries primarily produce estrogen, so estrogen starts to rise during puberty before sort of settling into these monthly oscillations or cycles. Women who become pregnant often experience a big spike in estrogen during pregnancy that really falls precipitously when they give birth. And in addition, we're starting to understand these fluctuations in estrogen levels that happen around perimenopause before the sort of natural decline in estrogen during aging. So men, too, actually have their own hormone roller coaster. I think a lot of men don't actually know this, but testosterone gets converted to estrogen in the male brain. So the testosterone roller coaster looks a little bit different. So testosterone also starts to rise during puberty and then has its own oscillations that kind of obey fluctuations both annually and daily, but men also experience these pulses of testosterone timed to specific life events before a decay and natural aging. So today, when I talk about estrogen men, I'm talking about you too. Yes. So the reason why we care so much about these fluctuations is that we know that these epochs of rapid change seem to be critical windows of vulnerability for mood disorders, and particularly these drops from high to low. And you can almost think of this as kind of a hormone withdrawal state. So a bunch of different types of depression seem to occur during this withdrawal state. Some, like postpartum and perimenopausal depression, are specific to women, and others affect both sexes. But what these types of depression have in common is a lot of symptomatology. More specifically, people who have these types of depression report a loss of energy or fatigue, which is something that we know that hormones are really intricately involved with. But also people report a loss of executive or cognitive functioning, which is they just feel like their brains just aren't working properly. So this is the thing that we're really interested in. So you might be asking yourself, so there are all these fluctuations, why can't we just take hormone supplements to fix the problem? I mean, you can, and hormone supplements are great for many things, but I'm going to argue that the hormone supplement is kind of like a sledgehammer when what we need is a scalpel. And the reason I say this is that hormone receptors, in particular estrogen receptors, are everywhere in the body, in men and women, right? You have estrogen receptors in your brain, as you might expect from something that affects cognitive functioning, and also in your reproductive tract. But you also have estrogen receptors in your heart, your lungs, your GI tract, and even in your bones. So if we're going to start from scratch, trying to make a new therapy, we might not want to, that affects the brain, we might not want to be affecting our bones at the same time as well. Okay, so how do we even start to design a scalpel for mood disorders? So my approach, right, we work in mice in these preclinical models, is that we develop this very customized AI to track behavior and neural activity across hormone states. So this is just an example of what an experiment looks like. We're tracking the activity of this green mouse as she's moving around, living her mouse life, kind of interacting with her mouse friends. And every tick down below represents a spike of a neuron in that mouse's brain as she's behaving. And what we do with this data is we design these very customized algorithms to measure what estrogen is doing to brain functioning in real time. Okay, in using this type of data, we've made some kind of interesting discoveries. So we've found a couple of novel biomarkers, these quantifiable metrics, that really tell us something about the animal's hormone state. So what we found is this one property that we're calling state flickering. So what we observe is that so state flickering is, what we call state flickering is really a mismatch between what the brain is doing and what behavior is doing, right? So when it doesn't match. So when estrogen levels are high, we see that the brain is really locked into what the behavior is doing. It's not flickering around. But when estrogen levels are low, we see this flickering is happening all over the place, almost like the mind is wandering. In parallel, we can kind of treat the brain like a social network, and we can ask how neurons are talking to each other. And what we see is that when estrogen levels are high, the connectivity between neurons is also really high. They have a lot of neighbors that they're talking to. And this connectivity really falls apart when estrogen levels drop. So you can really think about this as the brain kind of oscillating between two different states, maybe one that's a little bit more rigid and one that's a little bit more flexible. Neither is really good or bad, but they both might be optimized for different things. So what we really want to know, though, is this kind of black box. What's happening in the transition between these two states? Why does this create this window of vulnerability for depression? And in collaboration with OneMind, that's exactly what we're doing. So we're using what we've learned to kind of look at the steepness of this curve. So first, we've invented these optical tools that are going to really let us track sort of what the trajectory of this estrogen level is. We don't just care about what's happening when hormones are high or hormones are low, but now we can use these tools to actually take pictures of the brain all the way down this curve, and then in tandem track our biomarkers as a measure of depression risk. And in parallel, we're trying to develop a suite of molecular tools to kind of ease this hormone withdrawal state. So the goal of this is really slow this transition from this more stable state to this slightly more destabilized state. And you can really think about this as a brain-specific scalpel for mental health. And finally, just zooming out, although I've talked about all of this in the context of depression, right, this really has an application, had many applications beyond depression. So maybe in a strategic partnership with OneMind, I'd really like to think about how we can best use this data in the future. So now if we have the ability to track hormone states across the lifespan, we can make a difference not just in depression, but in a whole host of other disorders that have links to hormone, including things like the natural process of aging. And in addition, if we can get this kind of data into patient hands, it's going to allow them to make better, more personalized decisions about their healthcare, and even better decisions about how they move through the world. So that's our vision. So thank you so much.